day, everyone. Today, I will be discussing the results of my lab experiment titled Acceleration, No Speed. Before I proceed, I will present to you the objectives and materials used in this experiment. This is the experimental setup we use in this experiment. As you can see, we use an air track. In our data collection, we have two experimental setups, one for block wide side down, and the other is block narrow side down. First, tackling block wide side down, we can see the table of values and the graph for the time average squared. The slope of this graph is 0.1299 meters per second, and the acceleration, which is solved through the formula acceleration is twice the slope, is 0.2597 meters per second squared. Moving on to the block narrow side down, we see the table of values and the graph for time average squared. Its slope is 0.2532, and its acceleration is 0.563 meters per second squared. Going into the data analysis, the accelerations of both graphs were different. The wide side down graph has an acceleration of 0.2597 meters per second squared, while the narrow side down has an acceleration of 0.5063 meters per second squared. It was noticeable that the block narrow side down values in terms of time were shorter compared to block wide side down. When we compare their acceleration, the narrow graph is basically twice the acceleration of the wide side. An explanation for this is the difference of the orientation of the block that causes the air track's inclination. The block with the orientation narrow side down creates a wider angle compared to the wide side down. In this scenario, where there is no friction, there is only one force that is acting upon the object and causing it to accelerate. This would be its weight, which is affected by the amount of force and the angle of the incline. It could also be said that the greater the tilt of the surface, the faster the rate at which the object will slide down. Now that the necessary ideas and concepts are established, this justifies why the block narrow side down has a faster acceleration. Moving on to the second part of the data analysis, theoretically, if the air track was tilted perpendicular to the floor, its acceleration should be negative 9.8 meters per second squared. The only force acting upon the object would be the gravity, which has a constant value. So, to solve for the degree of error, we used a computer-generated graph, which we compared the slopes of both graphs, the computer-generated and the hand-drawn. This will give us percentage error. For the block wide side down, our error would be 4.20%, and for the narrow side down, our error would be 2.80%. This experiment tackles the concept of uniformly accelerated motion. As we saw in the experiment, the object was uniformly accelerating because there was no other force other than weight interacting with it, as we know that the air track was negating the frictional force. Now going into the objectives, we will discuss the relationship between time, position, and acceleration. And we found out that they are closely tied together because the very definition of acceleration is the rate of change in velocity over a certain period of time. And the definition of velocity would be the object's displacement over time. As we know in the position time graph shown, its slope is actually the velocity, and there is a formula of acceleration, which is slope is 1/2 of the acceleration, or basically acceleration is twice the slope. Our second objective is the concept between acceleration and the inclined surfaces, or the relationship. Now, the saying is the steeper the surface, the faster the acceleration, because as you know that in these types of motion, weight is a big factor in the x-axis. So we also consider that in inclined planes, the wider the angle is, the bigger the force it allows to interact with the object. For recommendations, first is to lessen the degree of error in the results. There are a few ways that we can prevent this or measures we can use. First is tackling in the graphing section. What we can do is, especially when you're using hand-drawn graphs, we should make the points as accurate as possible. And when creating our best fit line, we must try to hit as much points as possible. This type of error is classified as personal error, which is pretty much impossible to avoid. However, when we do it carefully and follow careful procedures, we can reduce the degree of error. Next would be in the experimentation itself. When we record the data, there are a lot of factors involved in this. Like as mentioned, there could be the capacity of the blower, maybe not at full capacity when the data was recorded. And also, maybe there are some malfunction on the instrument used.